In this tutorial, we're going to learn about isochrones, which are a way of calculating a more accurate distance from a point than a buffer in order to see how long it would take to walk there, to bike there, drive, take public transit. When we're using a buffer, all we're doing is setting a radius around a point, or it can be a line in a polygon. And we're doing that based on a simple radius or a distance as the crow flies. An isochrone is going to show you an area around another place based on how long it would actually take to move there using different modes of transit. So it's not going to be a simple radius as we saw with buffers. And this tutorial is going to get a bit more complex. We're going to combine a few different geoprocessing tools and other things we've learned, as well as install a new plugin and use that. To start off, I'm going to add a layer of community districts and subways. I'm going to put the subways above the community districts. And let's say that in this case, I want to see where in my community district or community district 4 in Queens, how much of that community district is within a 5-minute walk of a subway station. So first, I'm going to simply select this community district, which again is Queens 4. I have to make sure that layer is selected in the left-hand menu, and then I can just use my simple select features by area tool. And then I'm going to export and save selected features as community district 404. Oops, I need to put it here in the folder. So CD 404 is what I'm going to call it, and I'll add it to my map. And now I'll just turn off the other community districts layer. And I'm also going to clip subway stations to just this community district. So I'll go here to find the clip tool. It's in geoprocessing. So I'm going to put subway stations as my clip, as my input layer, and CD404 as the overlay layer, and run it. And it made this clipped layer, which is a temporary layer. So if I turn off subway stations, I'm going to see it. So now I want to calculate that isochrone on these subway stations. And I see 10 subway stations that fall within this community district. So I'm going to first download a plugin called TravelTime. I'm going to go here to plugins, manage and install, and I'm going to search for TravelTime and install it. So the TravelTime toolbar has now appeared in the upper part of the window. If I can't find it, I can go to help and just look for TravelTime and then find it through the menu. I'm also going to save this clipped subways layer as a permanent layer as subways CD404. Save. Okay. This is now a permanent layer. And I'm going to click on show the toolbox for TravelTime. And I need to set up the configuration for TravelTime with an app ID and an app API key, because TravelTime has limits on how many calls you can make under the free tier, and they charge if you go past a certain number of API calls. So when I'm doing this for the first time, I'm going to click get a free API key, but you're going to create an account. So once you've logged into your account, you're going to be able to get an application ID and an API key here in your profile. And then you're going to copy those over to QGIS. And click OK. So now you're going to be able to use this time map tool. So the input is going to be this clipped layer. For search type, I'm just going to leave it on departure because it doesn't make a big difference in this case. I will use walking and then travel time for 5 minutes. And I did walking here, but you have plenty of other options, kind of similar to when you are looking at how to get from one place to another in Google Maps. You have all of these different methods of transit. And so this tool can calculate the area where you can get to in a certain amount of time by any of these different modes. And I'll keep everything else the same, except here in advanced parameters, I'm going to click robust mode, which is going to allow the tool to run even if it's running up against its cap of API calls. So I'm going to click run here. I might get some errors because I ran up against that API call limit, but it's still going to have produced some results. So what I'm going to do is I'm just going to run it again. And now it created the isochrones for the subway stops that it didn't run the first time around. But what we've got here in our layers is 2 outputs, and I want to combine those. Each of them only has some of the isochrones that we need. So here we've got 10, and in this one, we have 6. So I'm going to use a function called merge to combine these 2 outputs into a single layer, and that's under data management tools and merge vector layers. So my inputs, I will select those 2 outputs, and I can just put this into EPSG 2263 and run it. And so now if I click off output, I have this merged temporary layer. And this is now showing me all of the areas in Queens Community District 4 that are walkable within 5 minutes. And I'm going to do a couple more geoprocessing functions on it just to get it exactly how I want. Let's say in this map I'm creating, I don't want there to be these overlapping separate polygons, but I would like it to be combined into one. And because I'm just looking at Community District 4, I'm going to also clip it to just the community district. Before I do that, I'm also going to change the symbology so that I can see the community district as an outline as opposed to a filled in polygon by changing the fill style to no brush. The stroke color, I will make that a similar bright purple, and I'm going to increase the stroke width. I'll apply it. I'll make that a little bit lighter of a color to show up more against the dark background. And then I'm going to do a dissolve on the merged layer. So dissolve is going to be here in geoprocessing tools, and dissolve is going to combine all of these different polygons into a single shape and a single feature. So merged up here had 16 total features, but I'm going to turn that off, and I've got dissolved underneath it, and that only has 1 single feature. Everything is combined together. I'm also going to clip it. So let me just remove some of these layers that I don't need anymore. These were temporary layers, so I will completely lose them by getting rid of them. And so last thing I'll do is just clip dissolved to CD404. The input layer is going to be dissolved and the overlay layer will be CD404. And I'm going to run that. Turn off dissolved, take it out of my project. And I will save clipped as a permanent layer. Walkable 5min. Going to change the layer name to walkable in 5 minutes. Walkable to a subway in 5 minutes. Change the symbology to make it a bit more transparent. And I can do that just by reducing the opacity here. See how that looks. Okay, I'll say that's okay for now. And then this layer that's currently still called clipped on here is my CD for subway stations. I'll put that on the top. And I'm going to make those a little bit more visible by increasing the size, making them a contrasting color. And here is my map of Queens Community District 4 with all of the subway stations and the areas where you can reach a subway station within 5 minutes of walking. So with this, I could do some more analysis, for example, by calculating the total area of my new isochrones out of the total area of the community district to see what percent of the entire community district falls within a 5-minute walking distance from the subways. Or I could do something like taking Map Pluto and selecting all of the buildings that intersect with the isochrone and then seeing how many apartments are within a 5-minute walking distance. I could calculate that as a share of the total apartments within the district. There's a lot I could do with this. One thing to note about isochrones is that you have that kind of low threshold of how many it will run at one time. So that's why I showed this on the subway stations within a single community district. If you want to calculate an isochrone on a lot more points, for example, all of New York City's subway stations, you're going to have to go through that step of creating a new isochrone and then doing the merge many more times than I had to do in this example. So let's say that I am working on a profile of Queens Community District 4 to assess the neighborhood's subway accessibility. So I want to calculate how much of the community district is within a 5-minute walking distance from a subway station. So I'm going to do a calculation of the area of both the isochrone that I just created and the area of the entire community district, and then calculate the isochrone as a share of the community district to get the percentage that's within a 5-minute walking distance from a subway. So the first thing I'm going to do is put my project settings into the unit that I want to calculate areas in. And in this case, because we're dividing one by another, it's not actually that important, but I'd like to know what the total square mileage is of the isochrone and then the entire community district. I could do square meters, I could do square feet, but I'll go to project properties. In this case, by default, my units for distance measurement is in meters and units for area measurement is in square meters. And I'm going to change this to miles and square miles and hit OK. And now I'm going to calculate a new field for the isochrone and for the community district. So I'll start with the isochrone, which is labeled here as walkable to a subway in 5 minutes, by going to the field calculator. And I'm going to create a new field called square miles. And I'm going to define it as a decimal number because the square miles is going to be small. I'll keep the precision at 3. That's going to give me up to 3 decimal points. And then here in the geometry options, I can pick area. I want the one that has a $sign in front of it. And that's it. I'm just going to click OK. And then when I look at my attribute table, it says it's 0.52 square miles. And I will right click and then click toggle editing and save that layer. And then I'll do the same thing for CD 404. And for square miles, the community district is 2.358. Great. So all I need to do, let's see. So I'm going to save my changes. And now I'm going to calculate 0.52 divided by 2.358, which is 22.1%. And I'll just note that somewhere for myself.